A chlorine atom contains 17 electrons, 18 neutrons, and 17 protons. State the mass number of this chlorine atom. So if you remember, if you look inside an atom, the mass is basically the sum of the protons and neutrons inside the nucleus. The mass and the proton number, we must know the difference. The proton number, the atomic number, is just the number of protons, but the mass is the protons plus the neutrons. So this atom here would have an atomic number of 3 protons, and it have a mass of 7. 1, 2, 3, 4, 5, 6, 7. So you can also work out the number of neutrons by subtracting the mass by the number of protons, the atomic number. So state the mass number of this chlorine atom. You simply add 18 to 17 because there's 18 neutrons and 17 protons. Electrons have a negligible mass, so you do not account for those in the mass. Give the electronic configuration of this chlorine atom. So electron configuration is the number of electrons per shell, and it's written like this, for example, 2.8, etc. So we know there are 17 electrons here, so we just have to basically keep on doing this until we fill we use up 17 electrons. So remember, the first shell we can have 2, second shell up to 8, so now we're on to 10, so we have 7 more to distribute. So this next shell can take up to 8, but we've only got 7 left, so it would be 2.8.7. So 17 electrons, 2.8.7, 2 on the first, 10 on the next, then this adds up to 10, and then this one up to 17. So you keep a running total when you're doing this until you reach the amount of electrons. Describe what you would see if damp blue litmus paper is placed into chlorine gas. So you can see it here. What happens is it first turns red for 1 mark, and then eventually it will bleach or turn completely white for the second mark. Chlorine exists as diatomic molecules. Diatomic molecules are those which basically bond together, like nitrogen is a diatomic molecule, hydrogen is a diatomic molecule, all halogens are diatomic molecules. Basically, all gases are pretty much diatomic molecules. No, well, most gases are diatomic molecules. Most of the ones you'll deal with, apart from the noble gases or group 0 inert gases, because they're so stable, they don't need to bond with anything to have stability. In a molecule, 2 chlorine atoms are joined by a covalent bond. That means they share pairs of electrons. Describe what is meant by a covalent bond. When atoms share pairs of electrons, it's really important that you remember to say share pairs of electrons. That's where the marks come from, saying sharing pairs of electrons. So you can see here, these atoms that I've drawn are sharing 2 pairs of electrons. One pair is here, and another pair is here, and you can see that originally 1, 2, 3, 4, 5, 6, this atom had 6 electrons, and this one had 1, 2, 3, 4, 5, 6. I draw them as crosses and dots so you know which is the owner of the original electrons. So they both had 6. They needed 2 more electrons each, so because they needed 2 more, they share 2 pairs. So now these electrons count for both atoms. So here's again 2 pairs, but if we count them now, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So now they each have a full outer shell. Explain why chlorine is a gas rather than a liquid at room temperature. This is a really popular question with a very standard answer, so look out for it. Whenever they're asking about why something is a gas and something else is a liquid at the same temperature, it's to do with intermolecular forces. Basically, between molecules, you have forces called intermolecular forces, bonds, forces of attraction. Now, these are weaker in some molecules and stronger in others. So that means, for example, at room temperature, there might be enough energy to overcome this force of attraction and cause these bonds to break in some chemicals, so they evaporate and become a gas. Whereas in others, they're a bit stronger and they can hold together even at room temperature, so they remain as a liquid. So you'd say that the forces between the chlorine molecules are weak. They have weak intermolecular forces. So chlorine is a gas because it has weak intermolecular forces, and at room temperature, it's basically above chlorine's boiling point. When the gas hydrogen chloride, HCl, is dissolved in water, a solution forms. Blue litmus paper dipped in this solution turns red. Stay white, the litmus paper turns red. Well, blue litmus turns red when it detects an acid, so the solution is acidic. It contains hydrogen ions. So basically, when you dissolve hydrogen chloride into water, it splits up into hydrogen ions and chloride ions. And basically, the number of hydrogen ions dissolved in water will determine how acidic that solution is. So, just a bit of extra information for you.